Question 5.21. In a 5-choice task, subjects are asked to choose the stimulus that the experimenter has arbitrarily determined to be correct. The 10 subjects can only guess on the first trial. Plot the sampling distribution of the number of correct choices on trial 1. Okay, this is kind of a weird one, but let's take a look. So back to the lecture notes, chapter 5. We're going to scroll all the way down, past these scary ones. We got a scary one down here on the bottom. That's the one we're going to use. This is the one right here. Okay, this is the binomial distribution. So we're going to go ahead and calculate it for 0 correct, 1 correct, 2 correct, all the way up to 10 correct, okay? I'm not going to do them all. I'm just going to do like the first couple. All right, please hold. So from the problem, we know there's 10 subjects. It's going to be 10 trials. There's 5 possible choices, but only one of them is correct. So that means that everybody's got a 1 in 5 chance of getting it correct just by guessing. So we're going to find the probability that nobody got it correct, that one person got it correct, that 2, 3, all the way down to all 10 of them got correct, okay? That's the probabilities to be used with this crazy formula. And there it is right there. I'm going to explain what everything means. So X, all the little X's in here, that is the number of correct. So that's going to change, right? N is the total number of trials. N is always 10. P is the probability of the event happening. So there's 2 P's. P stands for probability outside here of the parentheses. Don't confuse that with the P inside the equation. The P inside the equation is the probability of the event happening, and that's 1 out of 5. And Q is the probability of the event not happening. So that's simply 1 minus 1 out of 5. So we're going to go ahead and put real numbers on there. So X is going to change. It's the only one that's going to change, right? We're going to start as X is 0. Then we're going to redo the second problem when X is 1. And then redo the third problem when X is 2, etc., all the way up to 10. I'm not going to do them, but you're going to do them. N is always 10 in this problem, right? There's 10 trials, 10 subjects. P is the probability that they're going to get it correct by chance, which is 1 out of 5. Which is a fraction, which turns into 0.2. And the probability that the event will not happen, that they won't guess properly, is 4 out of 5. So 1 minus 1 out of 5 is 4 out of 5, or 0.8. So let me say that again. The probability that they're going to get it correct is 0.2. The probability that they're not going to get it correct is 0.8. And then we're just going to plug and chug into this god-awful formula. And you're going to do it 11 times, right? 0 through 10 inclusive is 11. So let's start with the probability that nobody will get it right. So this C is 10, choose 0. This is a combination, combinatorics. It's taught in college algebra, and you probably don't remember it. Nobody does. But 10, choose 0. And we know the probability, P, is 0.2. Raised to the 0, that's what the X is, times 8, that's the probability that it won't happen, that's the Q, times 10 minus 0, again, N minus X. And then we're going to put it into the factorial formula, okay? So we got 10 choose 0 times 2.2 to the 0 times 0.8 to the 10. Now the rest is just math, right? N is 10, 10 factorial. 0 factorial is 1. So we're going to reduce this. 0 factorial is 1. And then we got 10 factorial over 10 factorial, which is the same number divided by itself, which is also 1. And any number raised to the 0 power is 1. Use your calculator if you don't believe me. So we got this part is 1. Second part is 1. 1 times 1 is 1. And then 0.8 raised to the 10th power is, we rounded it off to that, 0.1074. And that is your answer for the first one. In other words, the probability that all 10 of these guys will miss it is about 10.74%. I'm going to do the next one for you. Let's find the probability that only one person will get it right. So now you'll notice that our X has changed. It's no longer 0, it's 1. So every time you see an X up here, you're going to change it to 1. So we got 10, choose 1, 0.2 raised to the 1, 8 raised to the 10 minus 1. Cleaning that up a little bit. And again, we're going to change the x in this formula to 1. Now, 1 factorial is also 1. Don't make me explain why. But you'll notice that the 8.8 is now down to the 9, and 0.2 is to the 1. So we're going to go ahead and calculate out the exclamation part. That is called a, what is that called? A factorial. But again, 1 factorial is 1. So as a factor, we could just drop it, right? 1 times anything is anything, so it really don't need it. But now let's go ahead and reduce that. So 10 factorial is 10 times 9 times 8 all the way down to 1. 9 factorial is the same thing, 9 times 8 times 7 all the way down to 1. But you'll notice that these numbers are the same numbers. So when you divide 9 times 8 times 7 all the way to 1 by 9 times 8 times 7 all the way to 1, you get 1. Very nice. So 10 times 1 is just 10. Okay? So we're going to multiply 10 times 0.2 times 0.8 raised to the 9th power. That's that one. You go ahead and multiply everything out, and you should get 0.2684. So in other words, the probability that only one person will get it right out of 10 tries is 0.2684, and the probability that nobody would get it right is 1.074. And let's go ahead and do number 2. This is the last one I'm going to do for you because this video is getting kind of long. Let's find the probability of 2. So the probability of 2, you'll notice that we changed the x to a 2. So every time there was an x in the formula, we changed it to 2 and made all the changes accordingly. This became 10 factorial over 2 times 1, right? 2 factorial is 2 times 1. And then 8 factorial is 8 times 7 times 6. But we're going to use that same trick. 8 times 7 times 6 all the way down to 1, divided by 8 times 7 times 6 all the way down to 1. These guys cancel out. Bam! So we got 10 times 9, which is 90 on top, divided by 2 times 1, which is 2. We got 90 divided by 2, which last time I checked was 45. And then just multiply these guys out. So we got 45 times 0.04, 0.8 raised to the 8th power is 0.1687. So we get a grand total of 0.302, and that is the probability that 2 people will get it right. And so that's the process, right? So the probability nobody gets it right is that. Probably the 1 person gets it right is that. Probability that 2 people get is that, etc., etc. And you got to do this all the way up to 10. Takes forever. All right, but that's it. Hope this helps. MGZ out.